Okay, so we're back today talking about slope fields, and our goal is to be able to draw a slope for a differential equation, identify a slope field for a differential equation, and sketch a solution curve given some initial data. Okay, so we're going to be doing all of those things here. So the first thing we're going to look at is our goal is to draw what we call a slope field for a differential equation. A slope field is a graph of the slopes of the tangent lines of a family of functions. Okay, so we're going to take a look at a picture of that in a second, but before we do that, we're going to look at this differential equation right here. We're going to start by looking at dy dx equals x minus 1. And so we're going to separate our variables here. So I'm going to bring the dx over to the right side. That's going to leave me dy equals x minus 1 dx. Okay, so I'll integrate both sides just like we've been doing here the last couple of days. Integral of dy equals the integral of x minus 1 dx. And remember, when we integrate y all by itself, it's integrating 1 dy. Okay, so the integral of 1 is just y. And the integral on the right side of x is x squared over 2. And the integral of negative 1 is negative x. And then we have some value of plus c. Okay? So this is called a general solution. Okay? And this general solution, if we had an initial value with it, we could use that initial value to find a particular c value. So if we said, if so let's see, if given something like 3,7, okay, we could use this. We'd use it to find c, and once we found c, then you would have what's called a particular solution. Okay, so once c is found, you have a particular solution. But you got to think about it here, because I could choose almost any value for x and y for this particular equation, and it might not be pretty, but we could plug them in and find a c value that goes with that. And so one of the things we want to think about is that when we have this plus c over here, this plus c actually creates what we call a family of functions. Okay, so this is a family of functions. All right, and the reason we call it a family of functions is because until we know what c is, that c could be all kinds of different various numbers and things like that, so we end up with a whole variety of functions. Okay, so if you look at that function's a parabola, and again, depending on the value of c, we would have a very particular parabola, but right now all we have are a bunch of parabolas. So we're going to go down here and take a look at this picture down here to the left, and if you take a look at this, we've got a bunch of parabolas drawn here that would fit that family of functions, and you can see this is just a small grouping, and these go from negative 5 to 5. Actually, it looks like I went from negative 4 to 5 over here. But these parabolas are all defined by that family of functions depending on the value of c. Okay, and if you look at the right side of this, the right side depicts the slope field for the same function. So for instance, if I chose the I don't have the point 3,7, but let's say I chose the point, let's go through, O-U-G-H, spelled through wrong, T-H-R-O-U-G-H. Okay, so I'm going to go through the point 1, 2. Okay, so if I were to look at the single parabola through the point 1, 2, so here's 1, 2 there, that would be, if you look at that point right there, if we were to draw according to this slope field, you can see that this thing would go something like this to the left, and then something like this to the right, and you would see that parabola going through the point 1, 2. Okay, and you know, if I chose another one, I could choose a second one here. So I could do through the point, I don't know, you can see the vertices of these parabolas here are, even on the left side, all the vertices are right at +1. So if I choose another one, the easiest one to choose would be 1 comma, let's say, I don't know, -4. So I could come down 1 comma -4, and I could draw a parabola through there, and you just kind of follow the slope lines up, and they move up like that and like that. And so that would be the parabola through 1 -4. Okay, so what we're going to do is we're going to actually draw some of these slope fields. So we're going to take a look here at how do you actually draw a slope field. And so we're going to look at the function dy dx equals x minus 1. Now remember, dy dx is the slope. This is the slope. Okay, so what we're going to do is we're going to choose some points on this graph to the right. We're going to select a point. We're going to find the slope at the point. And we're going to graph the slope. And we'll talk about all those little dashed lines that you saw on the other side here. So in fact, you know what, I'm going to go back here for just a second. So if we look at the picture on the right, okay, you see all these little lines on this graph. Well, these guys here, these are tangent lines. Okay, these are little tiny tangent lines, and these particular tangent lines would have a negative slope. So if you look at the parabolas on the left side over here, if I were to go over to that point at -5, can I go down that far? -3, I'm not sure I can go over that far. How about, you know what, how about if I do this one instead? This one I'm going to do this point right here. So if you look at that point, -4, or -1, -4. Okay, so I'm down over in this area right about here on the left side. You can see that the parabola at that point has a negative slope. That's what that little line here indicates, is that it's a negative slope. And you'll notice that some of the lines are steeper than other lines, so that's a tangent line at that point on the parabola to the left. These little guys right here that are flat, these are also tangent lines. Okay, but these guys are at the bottom of the parabola, so these would have 0 slope. Those are the vertices of your parabola. And then these guys over here are positive tangent lines. All right, so that's what we're going to graph on the next page here. Is we're actually going to graph one of these slope fields and see if we can figure out what this thing looks like. All right. All right. So it says to select a point, find the slope at that point, and graph the slope. Okay. So what I'm going to do here is you can see that my slope field has a derivative of just x minus 1. So if I pick a point, okay, I'm going to make a little chart here, point, and I'm just going to start right at the middle of the graph at 0, 0. Okay, so I'm going to pick the point 0, 0. And then I'm going to plug that point into my slope. Okay, so this is dy dx. Okay, so actually I'm going to write out the first few here so you can see what's going on. So dy dx, our slope. And on the right side, I don't have a place to plug in a value for y, so I just plug in the x value. So this would be 0 minus 1. This is going to equal -1. So I have a slope of -1 at the point 0, 0. So I come over here and I just try and draw a slope of what looks to be -1. Doesn't have to be perfect, but as you see, they'll change here. So then I'm just going to move down a little bit, 0, -1. Okay. So again, plugging in for dy dx, and again, we're not finding dy. Well, we're finding dy dx, but we're not plugging anything in for dy or dx. So this would be dy dx again, and again plugging in the value of x only, because there's no y on the right side. We would get 0 minus 1 again. So we have another -1 slope at 0, -1. So I would try and make that one roughly the same slope as the previous one. Okay. If I go to 0, +1, okay, again you can kind of see that if I plug in 0 for x, I get 0 minus 1, which is -1 again. So even up here I have the same slope of -1. All right, so now I'm going to choose a different point, get off of 0 here. So let's try 1, 0. How's that? 1, 0. So if I plug in that one, we get dy dx, and that's going to equal So plugging in 1 for x, we get 1 minus 1, that's 0. Hey, look at that, 0 slope. That's just a flat line, so we would literally draw just a little flat line. Okay, so now I'll do 2 comma 0. Plugging in 2 for x, I get 2 minus 1, which is 1. So I have a positive 1 slope over here. Okay, and then maybe 3 comma 0. And if I plug in 3, I get 3 minus 1, which is 2. So now I've got a slope of 2. So now I just got a little steeper, so I want to draw that slope a little bit steeper. Okay, so I'm trying to adjust as I go here. And let's pick some other ones here. Let's go to, let's say 1 comma 1. Okay, again, I'm just plugging in for x, so this would be 1 minus 1. I still get a 0 slope there. And if I plug in, let's go to the negative side, negative 1 comma 1. All right, so now I've got negative 1 minus 1. That's going to be negative 2. So that's going to have a little bit steeper slope, negative 1, 1. That's going to be negative 2 right here. And I'm trying to draw them not too overly exaggerated. We'll keep going here. Let's try negative 1, 0. So negative 1 comma 0. dy dx equals negative 1 minus 1. So that's negative 2 again. So that's going to be the same steepness over there. And we'll jump around a little bit here. Let's try negative 2, 0. Negative 2 comma 0. So that's going to equal negative 2 minus 1. So now I'm at negative 3 for the slope there. So that's going to be even steeper than the previous one, so I'm going to go a little bit steeper there. And you can see that as we continue to do this, you know, some of these are going to just repeat. Okay, so when we were at 1 for x, all of the slopes would be 0. So going up 1, I don't care what the y value is, because we're not plugging in for y, all of these guys would be 0. As we move over to 2, all the slopes are positive 1. Okay, so they all stay at positive 1. Even if we go down here, they're still positive 1. As we move over to 3, they got a little bit steeper, and they would continue to be that steep all the way up the graph right here, all the way down the graph right here. And this is kind of starting to look like our previous one. Same thing on the negative side. We got negative 2 slopes here, negative 2 slopes here, negative 2, negative 2. Then they got even steeper, negative 3, negative 3, negative 3, and so on and so forth. And that continues as we go all the way up and down. So what we're looking at here again is another parabola of some sort. So if we were to start right here, you can see that the parabola would go, and I'm going to choose a different color here. Our parabola would be going up like this. Okay, something along those lines right there. And that's what a slope field creates. Okay, hopefully that makes sense there. Let's take a look at the next one. It says draw a slope field for dy dx equals x minus y. So this one is a little bit different because of the fact that it does have an x and a y in it. So we just want to kind of keep that in mind. So this time I need to be a little more careful. This one we would not be able to separate the variables on because it's subtraction with y, and you don't want to do dy dx plus y. You want to do y times or divided by y, something along those lines. So we can't separate, but we can still create a slope field for this. So I'm going to start off here. I'm going to try and arrange this one maybe a little bit differently here. So I'm going to do x and y, so that's going to be my point. See if I can draw a somewhat straight line here. And then once I plug those in, I will end up with dy dx. Okay, so this time we're not going to write out all the mathematics behind this. We'll just start picking some numbers and plugging them in here. So I'm going to start off with 0, 0 again. Okay, obviously if I plug in 0 and 0, 0 minus 0 is 0. Okay, so I would have a horizontal line there. And then maybe I'll go up the graph. So 0 and positive 1. Again, plugging in for x for 0 and y for 1, you would get a slope of negative 1. Okay, so we have a negative slope over on at 0, 1. So at 0, 2, again, plugging in for x and y, you would get negative 2. So that got a little bit steeper as we went up there. And you can envision at 3 we would be getting even steeper. So we'll go somewhere else here. Let's try a 0. How about a -1 here? So now we've got 0 for x, -1 for y. So we're going to do 0 minus a -1. That's going to be +1 down here. So now we have a +1 slope. All right, let's try a 0, -2 here. That's going to be a +2 slope. And so these are getting steeper and steeper. So you can kind of visualize these guys going like this. All right, well, the guys up top here are just getting steeper as well. Okay, and so we'll keep moving along here. Let's try a -1 for x and a 0 for y. So that's going to be -1 take away 0. That's going to be -1. So a -1 slope over here, something like that. Let's try -1, +1. So that would be -1 minus another 1 is going to be -2. So that just got steeper. Let's try a -1, 2. So that's -1 minus 2 more. So that's -3. That got even steeper here. All right. So I'm going to go, let's try a -1, -1. -1, -1. So that's going to be -1. And we have minus a -1. So that's going to be -1 plus 1. That's actually going to be 0 right here. This is getting interesting here. Okay. What else we have here? Let me extend my table here. Okay. And so let's try a +1, 0. Did we do that one? We didn't do +1, 0. So we've got 1 take away 0. That's going to be 1. So we've got a +1 here. And let's try 2, 0. That's going to be +2, it looks like. So you're getting steeper going that way. So if I plug in 3, 0, I'm going to get a slope of 3. So that's getting even steeper here. Okay. So there's a little bit difference in those two guys. So let's try a 1, 1. A 1, 1, we're going to get 0. 1 minus 1, that's going to be 0. So we got another flat one. So even at 2, 2, we're going to get 0. You can hopefully see that. So at 2, 2. At 3, 3, we're going to get 0. At 4, 4, we're going to get 0. Okay, so let's try a 1, 2. 1, 2. So that's 1 take away 2. That's going to be a -1 slope right there. So that's going to be a -1 right there. And let's keep going here. So you're not always going to get a great picture of what these things look like, but you don't need to, in many cases, determine exactly what the shape is. A lot of times they're just asking you for, you know, a few points on the graph. So today we're kind of overdoing it just to make sure that everybody's good with what we're doing here. So I'm going to try 1, -1. So that's going to be 1 plus 1. That's going to be a slope of 2 here. And then let's try a 2, -1. What do we get there? 2, -1. That's going to be 2 plus 1. That's going to be 3. That's a little bit steeper than the previous one. And so, you know, we could continue on like this and just keep going and going and going. But, you know, you can kind of start to see a pattern on some of these as well. For instance, if we did 2, 1, 2, 1, that would be 2 take away 1, which is 1, which matches the slopes of these other ones at 0, -1, 1, 0. So it looks like as we go up the diagonal here, we get slopes of 1 all the way up here. Okay, and so, you know, based on that, we might be able to figure out what our graph is looking like. Now, if you take a look at the picture below, I believe we actually have a picture of that graph. And so it says the slope field represents a family of solutions. The solution curve passing through the point 1 or 0, 1 is. Now that's not the point highlighted here, so just be careful on that. 0, 1 is actually right here. Okay, so I want to draw the solution curve. Now you can see that this thing gets pretty steep pretty quick coming up this way. So my solution curve may come up very steep right here, and then as it comes to the right side, it's almost horizontal right there. So there is some sort of a 0 slope here, and then it comes up to the right side like this. So I've got some sort of a graph like that, and most likely what we're seeing here is some type of a vertical asymptote along this line here. Okay, or not a vertical, but a slanted asymptote along that line there. Okay, so the solution curve, what about the solution curve passing through 2, 0? Okay, so if we go to 2, 0, that's this point right here, and you can kind of follow. Let's see here. This one's not quite as obvious here. At least in, so at 2, 0, we may be looking at. Well, we're definitely coming up against on this side here, and then it looks to me like we're kind of rolling down this way here as we come down the graph. So it looks like we're going to do something like that. Okay. So, and that may not be perfect, but it doesn't need to be perfect. It just needs to be relatively close. Okay? All right, that takes care of lesson 5 there.